Hello, my friends. Thank you very much for subscribing to our channel. Yesterday we proved that the value of this complicated expression must be divisible by 3. And meanwhile mentioned that the value of these two expressions can also be divisible by 3. In order to prove them, factorization is a key step. Generally speaking, it is easier to design a factorization question rather than answering it, as it is usually not easy to find the targeted factors in the process of factorizing an expression. But these expressions are exceptions, because the targeted factors here are relatively easier to find. Today, let's discuss how to factorize these two expressions. These two expressions have a very obvious feature. If we replace B with A, following by replacing C with B, and finally replace A with C, there is no change in the expression itself. In addition, each term has a factor that is the difference between A, B and C, or the difference between their homogeneous powers. What does it mean? It means that, if there is such an equation, where the value of such an expression equals 0, then A equals B equals C must be a solution to the equation. Therefore the three factors C minus B, A minus C, and B minus A can be our preferred targeted factors. Let's take the first expression as an example. There is one targeted factor in each term. We keep one of them first, for example, keep C minus B, and then calculate the other parts. For the other parts, we need to search for C minus B. Of course, it can also be the cube of C minus the cube of B, or the square of C minus the square of B. For the cube part, we use the formula for the difference of cube to get C minus B or B minus C. For the square part, we use the formula for the difference of square to get C minus B or B minus C. Finally, we pick up the common factor C minus B, sort out the rest, and prepare them to search for the next targeted factor. The first two terms appear to contain the square of A minus the square of B. These two terms contain B minus A, and the remaining two terms also contain B minus A. Let's sort them out one by one. The idea is the same as before, where every time we need to get the factor A minus B or B minus A. Then we pick up A minus B. And now we have C minus B and B minus A. And the remaining part is ready for the next targeted factor, which should naturally be C minus A. And the rest turns out to be A plus C plus B. If we feel that the form is not that symmetrical and doesn't look good enough, it is easy to change the order of the letters a little bit. So this factoring is not difficult, is it? What about the second expression? There are some difference of square over there. So we can first apply the formula for the difference of square. And the final result is the same as before. The question can be designed a little more difficult in a way of adding up these two expressions. But in fact it still has the two features, that first there is rotational symmetry between A, B, C. And second A equals B equals C can make the value of the expression equal to 0. So we can still factorize it in the same way. Of course, we don't really need to do it now, as we already know it is equal to twice the previous result. Thank you for watching, and see you next time.